Let's simplify a few more radicals with adding and subtracting them. We have to recognize that a radical is the same as a variable. If we're going to add and subtract them, they have to be identical. In other words, example 1, we have 4 times the square root of 3 minus 8 times the square root of 3. Well, our variable would be the same as our term would be the square root of 3. So we have 4 of them, and we're going to subtract 8 of the same thing. We have a negative 4 times the square root of 3. In example 2, we're looking for like terms again. The square root of 6, 3 times the square root of 6, 8 times the square root of 6, minus 2 times the square root of 6, and then we have a minus 5 that doesn't have any square root of 6. There are 3 of these terms that we can combine. We'll add the coefficients out front. 3 plus 8 is 11, minus 2 is 9, so we have 9 times the square root of 6, and then we just have to bring down our last term that doesn't match anything, our unlike term, it's minus 5. In example number 3, we have the square root of 11 plus the square root of 11. Well, understand the coefficient is 1, so I have 2 of those, 2 square root of 11s, plus just plain old the number 11, which is not a like term, it's not under the radical. And for example 4, I have 6 times the square root of 5 minus 5 times the square root of 5. Those are like terms, so I can combine them. I would have just plain 1 times the square root of 5, or the square root of 5, plus the final term is the square root of 2, which is not alike. Now, if I want to take example number 5 and take the cube root of 18 plus the cube root of 18 minus 4 times the cube root of 18, I just have to ask myself, how many cube root of 18s do I have? Well, this is 1 plus 1 would give me 2, minus 4 would give me a negative 2 times the cube root of 18. Example number 6, let's see what we do have here. I have the square root of 8 plus the square root of 9 plus the square root of 18 plus the square root of 81. Well, nothing's alike, so can I simplify them? I want to know if I can factor anything and come up with some like terms. Well, the square root of 8 does factor. I could think of the square root of 8 as the square root of 4 times 2. And then the square root of 9 is a perfect square already, so that's just the number 3. And the square root of 18, I could say, well, that's the factorization there. I could say 9 times 2 again. And then the square root of 81 does. Plus, we can go ahead and resolve the square root of 81, and that is just the number 9. Now, what do we have here? Well, I want the square root of 4 to be taken out from under this radical. So I can say that's 2 times the square root of 2 plus a 3 plus, and I can take the square root of 9 out from under this one. It's 3 times the square root of 2 plus the number 9. Now, where are terms that I can combine? Well, I've got 2 times the square root of 2 plus 3 times the square root of 2. That gives me 5 times the square root of 2. And then I've got a 3 and a 9. That will give me 12. So I've simplified all of those down to 5 times the square root of 2 plus 12. Example number 7 looks like I'm going to have to do some more factoring. I'm looking for perfect squares that are inside the number 45. I'll say 2 times the square root of 9 times the square root of 5. I'm going to go ahead and separate them. 9 times 5 would give me the 45 I needed. And then I'm going to say minus 2. And inside 20, I see the square root of 4 times the square root of 5. I just separated them into separate radicals to save us a step. Now, I can resolve the square root of 9. It's 2 times 3 times the square root of 5 minus 2 times the square root of 4 is 2 times the square root of 5. Let's do this multiplication. I now have 6 times the square root of 5, and I have minus 4 times the square root of 5. And these are like terms, so I can combine them. I end up with 2 times the square root of 5. Example number 8, I'm going to be doing some more combining. What I've got is 5 times the square root of x, which cannot be simplified any, so I'm just going to write that down, plus 4 times the square root of 4x. Well, that would be plus 4 times the square root of 4 times the square root of x. I'll just separate those out because 4 is a perfect square, minus 13 times the square root of x. Now, I can simplify a little bit. I can say 5 times the square root of x plus And this is 4 times 2, because the square root of 4 is 2. So I'll say 4 times 2 would be 8 times the square root of x minus 13 times the square root of x. Everything is now in the same form. They're all square root of x's. So all I have to do is combine these like terms. I say 8 plus 5 will give me 13 minus 13. Well, they're going to cancel. So I have 0. Number 9. I need to do a little bit of work here, but there's nothing that looks like it's going to help me too much. I'm going to see what I can do with this first term, the square root of 3x cubed. I can't do anything with the square root of 3, but I can say the square root of x squared times the square root of 3x. You understand, I just pulled out the part of the radical, the part under the radical that was a perfect square. Now I'm going to say plus 3x times the square root of x. Nothing there will simplify. I can simplify this first part. The square root of x is really x times the square root of 3x. And then I have plus 3x times the square root of x. Now, while they all look very similar, they are still not like terms. I have here x times the square root of 3x, and I have in the second one x times the square root of x. So there's nothing I can do to simplify. Let's look at example number 10. These are cube roots we're working with, so we have to think a little harder. First, I want to take 81 and see, is there a perfect cube inside 81? I'm getting used to that one. It is 27. And then I can multiply it times the cube root of 3. So I've just pulled out the perfect cube inside 81. And there's a perfect cube inside 24. It would be the cube root of 8. And I'll keep multiplying that times the cube root of 4, which is not a perfect cube. I'm sorry, the cube root of 3, sorry. All right, can I simplify? Well, the cube root of 27 can be simplified. It is 3, so I've got 3 times the cube root of 3 plus the cube root of 8 can be simplified. That's 2. 2 times the cube root of 3. Now I have like terms. These are both the cube root of 3's. So I can do math and add the coefficients. I say 3 plus 2 will give me 5 times the cube root of 3.